This is Unit 6, Section 5, Notes, Inverse Relations, and Functions. You should be excited. This is the last one for this chapter. Yay! Or you can be sad because that means there's a test coming up. Boo! Either way, let's get to work. Alright, so the first part of this is inverse functions and one-to-one functions. So all I have to do is give the inverse and then determine if it's one-to-one or not. So it's a yes or no. Alright, so before I do anything, let's go down here. Notice there's not a lot of space down here because there's not a lot to write. Alright, so I'm going to go ahead and do for inverse. So you write it as r to the negative 1. That's the notation, right? And you can see that on the problems above. You have r equals and it lists a bunch of numbers, and then you have r to the negative 1, and then that's where you're supposed to write stuff. So inverse simply means that you switch x and y. So I'm switching the place, that's all I'm doing. So if I have normally 1, 2, the inverse would be 2, 1. You just go backwards. Okay, that's all inverse is. Okay, one-to-one. That one is probably a new term. That just means both the relation, right? The first one, the r, so both r, the relation, and r to the negative 1, the inverse, are functions. That is the only thing that means. Okay, so both r and r negative 1 inverse are functions. Then it'd be yes. If they are not both functions, then it's a no. Okay? And that's it. That's all we need to know for now. On the graph, there's one other thing, but I'll explain that in a minute. Okay, so look at number 1. So r equals, and it gives us these 4 points. So now I want inverse of r, the inverse relation. So I'm going to go ahead and write the same thing. And all I do is take these, so I'm going to take these, each of these points, right? And I'm just going to write them backwards in reverse order. So the first one would be 5, negative 1. I don't know where that 5 went. So all I did was just take this one and put it first, this one, put it second. So I'm just switching the order. Okay, the next one would be 6, 1. The next one, negative 4, 3. The last one, 9, 4. That is my entire answer. That's my inverse relation. Now, one-to-one. Okay, so one-to-one. Both the relation and the inverse are functions. So remember, to be a function, x cannot be repeated. So if I look at all my x's, on the relation, I have negative 1, 1, 3, and 4. None of those repeat, so that is a function. I have to also check the inverse. So I have 5, 6, negative 4, and 9. None of those repeated. So since they are both functions, I would say yes, this is a one-to-one function. And if you want, you can cross out no. Okay, that's all we're doing on this. You label the inverse, write the inverse, and then circle yes or no. Alright, so let's look at 2. Now this is called a mapping. If you forgot, you should have learned this in Algebra 1. It's okay if you didn't. So notice I have x's on the left and they point to the y that they go to. So for my inverse, I'm just going to start at y and go backwards. That's it. So down here, well, if it'll let me zoom in, there we go. I'm going to go ahead and start. And I'm just going to go in order from top to bottom on the y. So if I start at 2, notice my arrow, I go backwards. This one goes to 3. So this one would be 2, 3. Okay, wow, that's weird looking parentheses. Alright, my next one, I have 5. I have 2 arrows, I have to do both. So I'm going to do the first one. So if I go back, this one goes to negative 3. So I have 5, negative 3. And then I do the other one, 5 to 1. Quit moving up. And then my last one, I start at 9, I go backwards to 0. Okay, so I need to make sure 1 to 1, yes or no. Well, let me erase all this just so I can point this out. So if I look at my x's on my relation, my original one, I can tell if it's a function if each x only has one arrow. Each of those only has one arrow, so my relation is a function. And then, of course, the inverse is the same as the first one. I have 2, 5, 5, 9. Now, because these repeat, that makes this not a function, so when it asks for 1 to 1, I would just put no. So, simple yes or no, and that's it. Alright, my last one. Notice I can't write an inverse relation for this. I'm not even going to show you how to graph an inverse for this one. It'd be too much. We don't need to do that. So the only thing I need to know looking at a graph is this a one-to-one function? And you think, well, how would I know that? So do you remember something called the vertical line test? That's how you tell if a function or a graph is a function. You just draw a vertical line, and if it ever crosses more than once, it's not a function, right? I'm going to do the same thing here, but because I'm doing an inverse, I'm going to do the horizontal line test. Yes, that is a thing. If your Algebra 1 teacher told you it's not, either they didn't know or they just don't want to confuse you. But horizontal line test is a real thing. It really works because you have to use it. So if I draw a horizontal line anywhere through here and it ever crosses more than once, like right here, that means it is not a one-to-one function. So I just go here, circle no, and I'm done. Okay? Now, if I drew a bunch of horizontal lines and it never crossed more than once, then it would be a one-to-one function. But this one is not. Okay? So, that is the inverse function and one-to-one functions. Now let's go down to B. Finding the inverse of functions. So now I give you a function and say, okay, what is the inverse of this? Alright, so remember what we just wrote above. Inverse means to switch x and y. So for here, I'm going to do the exact same thing. So I know it says f of x, and you're like, well, there's no y. That is y, actually. That's just the fancy way to write it. So if you really wanted to, I could, like, let me cross this out, and let's say that this is actually y equals, okay? So I have y equals negative 2/3 x plus 4. So to find the inverse, I switch x and y, and then I solve for y. So let's do that. So now I have, instead of y equals, I'm going to write x equals. Then we have 2/3 y plus 4. So the numbers never change, just x and y switch places, and now I solve for y. Okay, so if I'm solving for y, I would subtract 4 from both sides, right? So I can't, x minus 4 is just x minus 4. Because it's not a number, I can't really do anything, so I just leave it like that. Alright. Now, I want to get y by itself, and I have a fraction. And if you've remembered anything that I've taught before, or if you're in class and you've heard me in class say this, if you ever move a fraction to the other side, fractions flip. So this fraction will come over here, and negative 2/3 will become negative 3/2, and I will multiply by all of those. Well, not all, both, right? I distribute. So I need to distribute this fraction to both x and this negative 4. And that's how I will get my answer. So, negative 3/2 times x is just negative 3/2x. Negative 3/2 times negative 4, well, we have two negatives, that makes it plus. And then I would do, what, 4 times 3 is 12, divided by 2 is 6, equals, and then now that gives me y by itself. But, one last thing, this is not y, right? We had y to begin with. So I can't put y on both because that's not true. But let's go up here real quick. Remember on the relations how we had the r and the r to the negative 1. Now we have function, so the r just changes to y. So we have y equals, the other one would be y to the negative 1. So on here, all I do once I get my answer, I get to y, I just add a little negative 1, and that means that's my inverse function. That's all that is. So on all of these, your answer should be y to the negative 1 equals, and then whatever it is, right? And that's it. So I switch x and y, solve for y, and I'm done. Alright, so now you're thinking, oh man, look at that, it has a cube root. How in the world? Well, let me show you. So again, this f of x is just y, so I'm just going to write x equals cube root of y minus 1, and then plus 7. Okay, now I solve for y. So it's just like we've been doing when you have any other square root, cube root. Before I can get rid of the root, I have to move all the numbers outside. Okay, so this comes over here, the 7. That gives me x minus 7 equals cube root of y minus 1. Okay, and then, just like we've done before, whatever my index is what I will put as my exponent over here. So if my index were 2, it'd be squared. If it was 4, it'd be the 4th. Right? We've done this before. Hopefully you've been doing this. So now I have x minus 7 cubed equals, and then of course because I had moved my index, that goes over here. My cube root goes away. I just have y minus 1. And then of course, since I want y by itself, I would just put this 1 over here. And yes, I meant to write it right here because I can't add 1 inside the parentheses. Right? You can't change inside the parentheses, which is why it has to go outside. So my final answer would be x minus 7 cubed plus 1 is outside equals y. And then I just add my little inverse, negative 1, and that's it. So overall, not that bad. It was, what, 3 steps? Again, this just takes practice, and that's my answer. Alright, last one. 6. Well, last one on this page, I should say. We still have a few more. So again, same thing. I switch x and y. So I have x equals y plus 3 squared. Okay, now, this is just like we've done before. Again, you should recognize this. To get rid of this exponent, since it's squared, the opposite of square is a square root. Okay, so now I have square root of x equals y plus 3. I can just drop the parentheses, because really it's kind of like I took my exponent and just put it right here. Same thing that I did on this one. I took my index and I put it as an exponent. Well, if I have an exponent, then it becomes the index. It's the inverse, right? And then my last step, of course, is just to move this 3 over here. And again, just like parentheses, I cannot put something inside a square root that's already there. So my answer would be square root of x, and then outside minus 3 equals y to the negative 1. And that would be my final answer. Alright, so that is how to find an inverse. Again, switch x and y, solve for y. That's all we're doing. Alright, next page. Now we want to determine if these two are inverse or not. So I will show you 2 different ways that you can do this. Either way is fine with me. So I'll show you the way that all the books teach it, like the formal way to do it, and then I'll just show you what I do. So the first one is just how they want you to do it. And I say they, like, most math professors, math teachers, people who write textbooks. This is how they want you to do it. I mean, this works. I just don't really prefer doing it this way. So the first way you can do it is I would take So I would take this function right here, like one of them. So I would take one function, and I would actually plug that in. Whoa, why is that doing that? Don't do that. All right. For x. So let me show you what that looks like. So that means I would have f of x equals -4, and then instead of x, I would do parentheses and write this entire function on the right. X over 4 minus 5, and then I keep going, plus 5. So I have replaced x with this function. That's what they want you to do. And this works, don't get me wrong. It works every time. Okay, so if I do that, then I just kind of simplify and solve. And the goal, the whole reason of this is I should end up with only x and no numbers. And if I do, then that tells me, yes, this is inverse. If I don't, it tells me, no, it's not. Okay, so when I distribute this, I have -4 times x is -4x divided by 4, of course, is -x, or -1, right? And then -4 times -5 is plus 20. And then I combine like terms. 20 plus 5 is 25. And see how I get to here? I can't do anything else, and I'm left with -x plus 25. Well, because I didn't get x by itself, which is what I need to get, so if I get anything besides just x, then my answer would be not inverse. Okay? I can stop there. I don't have to do anything else. So you plug in one function for the other, and you simplify, and you should only get x. Now, if you want to look at my notes, I did that on the second one to show you what that looks like. So if you prefer that method, that is totally fine. You can do that on every single one of these, and you'll always get the right answer, assuming you do the math right. Now, let me show you how I would do this. To me, this is just easier. Because you're not having to do anything different, you just do what we did before. So just before this, when we found the inverse, remember you switch x and y and solve for y? I can do that. So I pick, and here's what I do. I can pick either the first one or the second one. It doesn't matter. And all I do is switch x and y and solve for y. I should get the other one, right? So if I start with the left one and I switch x and y, when I solve for y, I should end up with the right one. That would tell me yes. If I get something different, then that would tell me no. So, I don't know. So I mean, it doesn't matter which one you pick. So I'm going to go ahead and do the left one, right? So if I take the left one, I'm going to do x equals y squared plus 8. Alright, so now when we solve for y, of course I would subtract 8 first. Move that to the other side. That gives me x minus 8 equals y squared. And then of course I take my exponent 2 and I would make it an index, so square root. And so over here I would get square root of x minus 8 equals y to the -1. Alright, so look, I have square root of x minus 8. Now if I look over here, I have square root of x minus 8. Because I got the other function, that would say, yes, they are inverse. Now if you got anything different, or if it was plus 8, or if there was a negative somewhere, or any other numbers, then it would not be. So when you do this, you should get the exact same thing as the other one. Now I could have started with g and solved for the inverse. I would get f. So you can do this either way. I can plug it in like I did on 7, or I can just find the inverse on 8. Either way works, and if you do the math correctly, you'll always get the right answer. Okay, so you have two different ways you can pick. It doesn't bother me which one you want to do. Okay, and then the last one is find the inverse and graph both. Okay, So first thing I'm going to do is just simply solve for the inverse. So I switch x and y. I don't know why it does that. So I have x equals y squared minus 4. Okay, so I add 4 to both sides. That gives me x plus 4 equals y squared. And we just did one like, right above this that was the same. So the square becomes square root. And so this one would be square root of x plus 4 equals y. Okay, so that's my inverse, which is great. And now I got to graph both of them. Okay, so let's go ahead and just graph this square root because we have just learned about that, and so this one should probably be the easier one to do. So if you remember from graphing, there's my h, which is actually flipped, so my h is negative 4. And my k, since I don't have a number, like there's nothing here, my k would be 0. So if you're ever missing a number, it's just 0 as far as hk is, okay? And this is, my index is 2, right? This is a square root, so this would be an endpoint. So I'm going to go to negative 4, 0. Where's my graph? There it is. So I'm going to go ahead and graph this in red because this is our inverse. So I go to negative 4, 0. And then I'm going to graph this using the pattern that I taught y'all. So I go up 1, right 1 squared, up 2, right 2 squared, which is 4. Up 3, right 3 squared, which is 9. That'd be over here. And I'm going to graph that one, just like that. Okay, so I got the inverse one. Now I need to graph the regular, the original, okay? So this is a quadratic. So quadratic, remember this is, it's been a while since we've done this. But since I don't have any parentheses, my h is 0, my k is negative 4, and that's where I want to start. So I'm going to go here, and I'll graph this one in green. So 0, negative 4. Hey, look at that. Notice how it switched. My endpoint for here was, my first one was negative 4, 0. And now this one is 0, negative 4. Crazy. See how the x and y flipped? That would be inverse. Okay, so we're on the right track. Now, for a cube root, the red one, we went up and then right 1 squared, up 2, right 2 squared. For my original, my quadratic, I'm going to go right 1, up 1 squared. So it's just the opposite. Right 2, up 2 squared. Right 3, up 3 squared. Okay? So if I do that and I connect those dots, and you can do both sides if you want to. I'm only going to do the right side because on the square root we only went up to the right, and so on my other one I want to go up to the right. Same thing. And I can't really do this on here, but if you turn your paper, let me zoom out a little bit so I can show you. If you turn your paper and if you draw a line through the diagonal, then you should see a mirror image. If you notice, they cross each other, but it's just like a mirror. That's what you should see when you graph an inverse function. Okay, so they mirror along the diagonal, which the diagonal of course this line is y equals x, because if I switch x and y, that's what they should mirror. So I'm going across this line. Now if you graph 2 and you turn it and look through the diagonal and they are not a mirror image, then you've graphed something wrong. Hopefully that doesn't happen, but they should mirror across this line. And that's all we have to do on those. So we found the inverse, which we already knew how to do, and we graphed both functions, and the way you can tell again is just they mirror across that line. And that's it for the notes for this whole chapter. Crazy. Awesome. So, if you need anything else, let me know, ask questions. If you look at the notes I posted online, I might have some other things in there that I didn't really talk about or write down, but it might help you. So whatever you need, get what you need, and please practice the homework.